Oh, hey, what's up, everyone? Thanks for tuning in to the YouTube series, Moncton High Math. And right about now, we're about to tackle the factor theorem. Okay, this is going to be so lit. Let's check this out. So first of all, I put a technical mathematical definition, as I've been doing all along and will continue to do. If this looks complicated or anything like that, trust me, this is not. This is very simple to do. So basically what the factor theorem is it is a specific version of the remainder theorem. Okay, it is applying the remainder theorem, plugging numbers in for x, okay, to see what the remainder is, except that we're specifically looking for a remainder of 0. And of course, if you get a remainder of 0, if you divide two numbers and the remainder is 0, that means that they divide evenly into one another, which means that the numbers are factors. Okay, so you get factors of a number when things divide evenly. So let me just demonstrate using a number value only of 28 over here on the left side. Going back to grade 10, okay, if you factor 28, I can take 28 and divide it by 7. And I will get an answer of 4 with no remainder. So 7 is a factor of 28. I can also take 4 and divide even further. I can say, okay, well, I can take 4 and divide by 2 and get an answer of 2 with no remainder as well. In other words, the remainder is 0. So I've said here that 28 is equal to 7 times 2 times 2. Those are the factors that divided evenly into 28. So we're still looking for remainders. We're just specifically looking for a remainder of 0. So take a look at this one example that I have here. Is x minus 1 a factor of this polynomial? Well, the answer is either yes or no. So what we need to do is we need to do the remainder theorem, plug in a positive 1. Remember that you plug in the opposite value. So if I plug in a positive 1, I'm using the remainder theorem to determine the remainder. If I get a remainder of 0, then that means x minus 1 is a factor. So check out what I'm doing here. I'm trying to figure out what the remainder is. I'm using the order of operations. I'm doing exponents first and then multiplication. Perhaps you can do this quicker than what I'm doing. That's fine. Okay, but when you look at this, okay, you get 1 plus 2 minus 5 minus 6, which is an answer of negative 8. This does not equal 0, so you would say that x minus 1 is, you are, not the factor. Okay, if you had a remainder of 0, then x minus 1 would, yes, be the factor. So it's simple yes or no answer. You're basically looking to see if you get a remainder of 0 or not. So let's look at this second question. It's just more of the same thing. Perhaps you would like to pause this and try this on your own and then press play again and check to see if you have the right answer. If not, then you can just follow along with what I'm doing here. Is x plus 2 a factor of the polynomial? Okay, once again, okay, if you plug in a number for x, you're always plugging in the opposite of the factor. So I'm going to plug in a negative 2 for x, and I'm going to see what the remainder is when I take that degree 3 polynomial and divide by x plus 2. If I get a remainder of 0, it divides evenly, and it is a factor. So let's take a look at what I have here. Okay, maybe I'm skipping some steps this time, but you can see right here that if I add and subtract all these together, I get an answer of 4. Whether you used more steps than I did or not, okay, you can do the order of operations. You get a remainder of 4. Because there is a remainder that is not 0, okay, this does not equal 0, so we would say that x plus 2, you are, Maury Povich voice, not a factor. Okay, there are two questions here in the lower left corner here, page 133, numbers 2 and 3. They will not take you very long to do at all. You can do those in a few minutes, just testing out, are the binomials factors or not factors of the larger polynomial.